Hi, and welcome to this quick how to help video on simplifying surds. So a surd is a way, let's just write this down. A surd is a way of representing a number that if we actually put into the calculator would give us a number that just goes on and on into infinity. It's an irrational number, but we want to be able to work in that number without cutting some of it off and getting rid of it. So keeping it in its surd form means that we are keeping it accurate. It's a perfect number until I mess about with it. So I'm going to leave it as root 2 and I'm going to learn how to work in roots using certain rules. So let's just clean that off. It doesn't want to clean. Maybe it'll catch up in a minute. So let's look at root 3 times by root 7. If I put that in the calculator is going to give me root 21. And if I do root 5 and times it by root 11, I'll get root 55. And that starts to help us form this rule that helps when it comes to surds. I can see that generally what's happening here is that a number, and I'm going to call it A, can be multiplied by another number, which I'm going to call B, and that's going to equal root AB. Okay, a number that's been multiplied together. But it also works going in the opposite direction. So I can take my one single number, AB, and I can split it back out into root A and root B. Okay, now why might I need to do that? Okay, let's just keep that on the screen for a sec and look at this question. If I did root 8 times root 3 and put that in the calculator is going to give me 2 root 6. Now I would have written root 24 because 8 times 3 is 24. So the calculator is doing something to my root 24 to make it 2 root 6. And what it's doing is it's cancelling it down. It wants to use the smallest surd or root possible along with any integers to keep that value true, to keep it equivalent. And that's where this splitting will come in, okay? So I would have taken my root 24 and then I would have needed to look at that in a way that splits to help me simplify. To help me simplify, I need to find square numbers, okay? So root 4 and root 6 multiplied together, and you can show that time sign if it helps you. When they are multiplied together, they make my root 24. But the good thing about splitting it into 4 and 6, it means that here I've got a square number. I can actually perform the square root of 4 and get a whole number. I can get 2. So if I can find a whole number, I know I'm simplifying this down. I would then consider root 6 and think, right, well, that's split into some square numbers. It doesn't, which means I've gone as far as I can with that root. And my answer is 2 root 6, as we would expect from the calculator. So why do people get in a muddle with surds? Okay, when really it's just following a lot of the same rules of arithmetic. I think one of it is because we forget to do the roots. So if I was to say, right, I've got square root of 32 and I want to split this, some people will write 4 and 8 without putting the root signs on. The root sign is only going to disappear if you actually perform a square root. So it's really important to remember that we've got to split and show the root signs as well. Obviously, I have just found my square number, did that on purpose. So I've got 2. And then I need to consider this root here. Will it split and give me another square number? Yeah, it will, which means I haven't finished on that at all, because that will split into square root of 4 times the square root of 2, which means I can actually do that piece of maths to get 2. Then I ask the same question of the root 2. Will this split to give me a square number? No, it won't. You could argue it would, because 1 is a square number, but it's not going to simplify anything for me. So it's no use me going down that road. So I've gone as far as I can with that. I've got another integer there. So 2 times root 2 is going to give me 4. And then I squash it to the 2. I don't show the time sign and get my final answer. So one of the reasons is because students forget to show their root signs, or they do it on one and then they don't do it on the other. That's the type of thing that goes on. The other reason is because in class, they're glancing over at somebody and they're doing it differently. So they've written it and then they've split it as 16 and 2. And you're looking at yours and thinking, oh, well, I've gone wrong then. You haven't. They've just seen a different route to the end answer, to the result. So they've just spotted a bigger square number that they could have used. Square root of 16 is 4. Can I do any more on the root 2? No, I cannot. So here I go straight to 4 root 2. I go to the exact same answer. I just get there faster because I spotted a bigger square number within the number I was given. And that, I think, is why people sometimes allow this topic to get a little bit confusing for them. All right. So just like fractions, as I've been saying, that cancelling can be done in more than one way, but your end result will still be the correct answer. Okay. So this is a really, really important fact that you will see when it comes to application and problem solving, rationalizing denominators, and all sorts of other areas of Surds. And that is when we see the same number being multiplied. So I've got root 5 times root 5. Okay. Now that, if we follow the rules we've just learned, is root 25, which is 5. So what's actually happening is a cancelling of the root. If I'd written it like this, root 5 times root 5 equals the number multiplied by itself, you can kind of see that power 2 and that square root, the inverse of each other, just coming along and cancelling each other out. So we are getting that equals 5. So whenever you've got the same value in the multiplication, just cancels out. Really, really important piece of knowledge when it comes to our Surds work. So we've got to be mindful of that. All right, let's do a more complicated simplification with our multiplication. So one question that you might see is something like 2 root 6 times 3 root 8. Okay, it's still going to follow the same rules. Remember that the 2 and the root 6 being squashed together has that kind of invisible time sign. So what I'm going to be doing is separating this out. I got 2 times root 6 times 3 times root 8. And then I'm going to reorder this. So I've got all the integers together and the roots together. And then I can start my tidying up. Obviously, I can do this. 2 times 3 is 6. And I can do what I know about my multiplication of surds. And that will give me 6 times root 48. Now I can squash that together, but before I do that, I'm going to just consider that root 48. Is that something that I can cancel down and make a little bit easier for myself? Okay, I'm going to do probably the most obvious that students would see, which is going to be the 4 and the 12. So yes, it's going to split into 4 and 12. I've got my square number on this to give me 2, gone as far as I can. Here, I've got to ask that question, will it go again? And yes, it will. It's going to go by root 4 times root 3. And that's going to give me 2. And I can't do any more with that. So I've done everything I can on this root 48. But I must not forget this 6, this whole number over here, is part of my question. So my final answer is the 6 times 2 times 2 times root 3. I've got myself down to having just one root in the answer. 6 times 2 is 12, times 2 is 24. So I've got 24 root 3. So just break it apart and then put it back together and then work on that single root that you've got until you've simplified it fully. Okay. Simplifying when it's a division. Okay, that's going to look like this. I've got the square root of m over the square root of n. And the rule is square root of m over n and vice versa. So I'm going to be using that rule to my advantage and doing it in the order that works for me. Okay, so for example, if I had root 14 divided by 25, I would change that to root 14 over root 25, and that would give me root 14, I can't do anything with that, over 5. And that's the simplified version of my original question. There we go, clean that up. Okay, I could be given more complicated questions. So I could be given root 6 times root 12 all over root 3. And again, there's more than one root, more than one way to think about this question. If we just follow the rules exactly, then I could say, okay, I've got root 72 on the top and I've got root 3 on the bottom. I could then go on and wrap a root around the whole lot so that I can have a fraction on that inside. That will cancel to a whole number. So then that would give me root 24. Ooh, just about see it. Let's bring the whole thing down. There we go. And then I would consider my root 24, which again is root 4 times root 6. That gives me 2. That doesn't do anything more. So 2 root 6 being my final answer. Okay. But as you become more confident with your roots, you will start to see other ways, because like I say, it follows many of the rules of arithmetic of what we know. So let's put that there so we don't lose it completely. So let's say I had root 6 times root 12 over root 3. I could have paired these up and said, okay, root 6 divided by root 3 is going to be root 2. So I've got root 2 times 12, which equals root 24. And away I go with the splitting. I could have done, let's write the question again, root 6 times root 12 over root 3. I could have done it by matching these. Root 12 divided by root 3, okay, means I can cancel it off of there. That's what happened here as well. I cancelled the root 3 because I divided it into the root 6. I'm going to cancel the root 3 because I'm going to divide it into the root 12 to give me root 4. Root 4 goes straight to 2. So I'm left with 2 root 6. And actually, I don't even need to do any more work with that particular way. And I hope I haven't confused you. I hope what I've done is demonstrate exactly why our roots can be, tricky little suckers, because there is more than one way to work your way around the problem. And I really think it is just practice makes perfect. You know, you've just got to find that exercise, get lots of questions and just practice like mad. So I'm going to leave it there. I'm going to rationalize the denominator in a separate video, and then we'll look at some problem solvings in another one on top. So fingers crossed you found this useful. If you want to look at the ongoing videos coming up on Surds, then I've attached them to a playlist, so they should roll on. All right, thank you very much for joining me.